Now we will look at the code of the producer process. In this figure, you can see that we have a producer and a consumer process. The two triangles over here show you the two semaphores in use. Both semaphores are in use by both processes as shown by the dashed lines. Before we look at the code of the producer process, we have this slide which is showing you a pattern. In the consumer process, you have a while loop. Inside the while loop, there is a call to semWait and semPost. The wait and post calls are on different semaphores. In the producer process, we will also have a while loop. Inside the while loop, there will be a semWait in the beginning and a semPost at the end. So if you carefully notice, there is a pattern. The consumer process performs a wait on the fulls semaphore, semIDF. It performs a post on the empties semaphore, and the producer process will perform a wait on semIDE, the empties, and a post on semIDF, the fulls. Moving on to the code of the producer process, here we have the header files, then we have some initial variables. This is very similar to the consumer process. And then we have the semopen calls. The producer process is different than the consumer process. Over here we are using the two parameter form of the semopen. The reason is that the semaphore is already created by the consumer process. The producer process will use the existing semaphores already created. The return values of both calls are inspected for errors. Everything is well and good. Then we have SHM get. SHM get will get a handle on the shared memory. Notice that the key value over here 1, 2, 3, 4 should match the one which has been used in the consumer process. This makes sure that a new separate shared memory is not created. The key values must match. The return value is inspected for errors, and then we have the same steps like in the consumer process. SHM80 will be used by the producer process to attach to the shared memory. SHM80 will return a void pointer. This pointer must be properly cast, and you can see the casting statement over here. This has already been explained in the consumer process. And then we arrive at the main operating loop of the producer process. The producer process is going to first call a semWait on semIDE. Notice that over here it has been done with proper error checking. And this is how you should always use semWait and semPost. And in production, you should always do error checking as shown over here. So the producer process will first call a semWait on the empty semaphore, semIDE over here. Then it is going to prompt the user by displaying a line, enter some text. That text is captured from standard input, and after that it is going to be copied into the shared memory. So strncpy is going to copy the text entered by the user into the shared memory. Also, the strncmp is used to compare the text entered by the user against the word end. If the first three letters of the text entered by the user match the word end, then this flag running is set to 0, which will break the producer out of this loop. And finally, after this if condition, there is a call to semPost. Notice that this is also done along with error checking inside this if expression. So in a nutshell, in addition to the semWait and semPost calls, the producer process is going to prompt the user to enter some text and copy that text into the shared memory. Once it is out of the while loop, the producer process will simply detach itself from the shared memory and exit. And that's the producer process. These are the set of resources which were used. Here you can see the sample output run of executing both processes in two separate terminal windows. Once again, remember that the consumer process must be started first. Once it is up and running, it will wait for the producer process to proceed and deposit some text in the shared memory, As you can see on the right, as text is entered in the producer process, it will gradually appear in the terminal of the consumer process. And finally, when end is typed on the right terminal window, the producer process will terminate, and eventually the consumer process will also detect the same, and it will also terminate.